another episode of the Dark Assassins podcast, the show that dives deep into not just technology, but the concepts, software, and procedures behind it all, and explains it so simply that even your grandma can understand it. As always, I'm your host, the Dark Assassin. I hope you all had a great Thanksgiving, and for those of you who are still recovering from your various food comas over the past few days, hopefully you are doing all right as well. Now, about a month or two ago, I believe it was about 2 months ago at this point, we did a episode where we compared various objects such as car transmissions and other various things to programming languages. And seeing that this is the Thanksgiving special, I figured we'd have some fun this week and compare various Thanksgiving food items to things you'd find in a home lab. Now, I thought about also comparing the various Thanksgiving food items to programming languages, but the issue I kind of ran into when kind of thinking about that was everything at Thanksgiving kind of complements one another, whereas programming languages are kind of their own siloed, standalone thing. Now, granted, there are some languages that work pretty well together, like C works with C++, HTML, CSS, and JavaScript all kind of work together too, but for the most part, languages are kind of their own standalone thing for the most part. I mean, sure, you can integrate them through things like APIs and like socket functions, or not functions, but sockets and networking, and you can connect them, but they're not like as hand in hand as like things like Homelab services are. So that's why I decided to go with Homelabs rather than programming languages. But I'm sure to have missed something or have given the wrong Homelab equivalent to a food item. So if I did, be sure to sound off in an email or in the comments below if you're on YouTube. And while you're there, also make sure that you're subscribed to the Dark Assassins podcast, and also like and rate and all that good stuff too. But before we get into the meat and potatoes, or I guess the turkey and mashed potatoes of the episode, let's start off with our trivia question. So in the spirit of Thanksgiving, I'm going to give you guys an easy Thanksgiving-themed trivia question. So a recipe is a common analogy for what computer science and mathematical term defined as a sequence of steps or instructions to solve a given problem? So what is that analogy that a recipe is common for? And that is your trivia question for the week. Now, moving right into this week's cybersecurity tip. This week's cybersecurity tip is to avoid common software vulnerabilities when writing code. Now, I know that's a lot easier said than done, but knowing is half the battle, as they say. And if you're aware of some of the most common forms of software vulnerabilities, that will put you in a much better position to kind of understand when those types of vulnerabilities could arise. And when you're writing, your programs, you can kind of identify those places and be a little more cautious in your implementation as to not fall into those common vulnerabilities. Like a good one, for example, is if you're ever dealing with SQL commands in your code, make sure that you're actually parsing and validating the SQL and not piping user input directly into it. Also, checking buffer bounds so you don't, overflow buffers. Things like this are kind of some things that you can know, even if you don't necessarily know the exact mitigation steps per se. You at least are aware of where these vulnerabilities can creep up in order to be, more cognizant when it actually happens in your code and have a better chance to recognize it and stop it before it happens. So I wanted to kind of go through some of the most common software vulnerabilities. So There is the MITRE framework, I guess. They have a website where they kind of list out some of the most common vulnerabilities and kind of rank them. I think it was the top 25. I'll have it linked in the show notes below. The first one here is improper neutralization of input during web page generation, aka cross-site scripting. If you are a web developer, this probably affects you a lot more than it affects someone that doesn't deal with web development. Number 2 is the out-of-bounds write. So a classic memory safety vulnerability where you try to write, outside the bounds of an array, whether that's some kind of buffer overflow or you just index to a value in an array that doesn't exist and end up writing to or reading from arbitrary memory. Next one is the SQL injection. We kind of touched on that one already. Another kind of more web-focused one, cross-site request forgery. The next one is path traversal or improper limitation of path names in a restricted directory. So basically you allow someone to access a directory they shouldn't have access to. Kind of in the same veins of the out-of-bound write is the out-of-bounds read. So you are trying to read from data that you shouldn't have access to in an array. The next one is a command injection, and the one thing about command injections is it doesn't really matter which programming language you're in. It's something that can kind of occur in almost any language, right? So it's not like if you use a memory safe language, you're safe from OS command injection, because if you ever take user input and then pipe that to a system command, that is a common instance for an OS command injection, kind of similar to the SQL injection. Next one here is use after free. So we kind of talked about this one fairly extensively, I think a couple weeks ago, essentially where you free memory, but it is still technically within the scope of the function of the program or whatever, and then you end up calling it again, and because that memory address is still valid, it's technically pointing to something, so you can manipulate freed memory even though when you shouldn't be able to. Next one, missing authorization. Number 10, unrestricted upload of file with a dangerous type. So this one, pretty much if you're ever doing any kind of server-end programming, making sure you validate the types of files that are being uploaded, whether you can do it server-side or client-side to maybe prevent things like this from happening, because there have been instances, I think PHP was one of them, where if you uploaded like a malicious file, whether it was PHP or otherwise, it would try to execute it and bad things would happen. Next one, improper control of generation of code or code injection. Improper input validation here is a classic one. Next one is command injection, I guess kind of similar to OS injection, except more, I guess, generalized. Improper authentication, improper privilege management. That is definitely a big one, since you don't want if you're running like multiple processes, you don't want a user to potentially be able to access processes that they shouldn't have access to. Deserialization of untrusted data. Exposure of sensitive information to an unauthorized actor. That's kind of another one where you want to make sure that the person who is requesting information, regardless of what it is, actually has the privileges and or the need to have access to that information before you give it to them. Incorrect authorization, server-side request forgery, improper restriction of operations with bounds of a memory buffer, classic. Null pointer dereferences, another classic in memory unsafe languages. Use of hard-coded credentials. That's honestly pretty sad to see. Granted, it is it is 22 out of 25, so not nearly as high as it was last year. It has come down, looks like 4 spots, but still hard-coded credentials in source code is absolutely a big, huge no-no. You definitely don't want to be doing that. Integer overflow or wraparound. Now, this one I think is kind of a pretty... I don't know if I'd say common mistake. I mean, I guess I would since it's on this list. But it's a mistake that can happen to the best of folks. This is something that you really have to ensure you're thoroughly testing edge cases, because this is something that can happen where an integer overflow or wraparound is essentially where you are dealing with a signed integer, which essentially means, well, I guess wraparound works kind of in the same way too, but you're dealing with a signed integer. Let's just go with an 8-bit integer. So if it's a signed 8-bit integer, the max number you can go up to is 127, I believe. And then if you go one over that, then you wrap around to the negative value, which would be negative 128. And that's obviously not good, because depending on how you are working with your code, that could potentially cause issues in your code if you weren't expecting a negative number to occur. And then the other one being the wraparound, where if you get past the maximum value that integer type can hold, you go back to 0 if you're dealing with an unsigned integer. And again, the difference between signed and unsigned is the uppermost bit in the integer basically determines if this is a positive or negative number. If it's a signed integer, if it's unsigned, it just acts like a normal number. So that's kind of that one. Uncontrolled resource consumption, and then the last one being missing authentication for critical function. So those are some of the most common types of software weaknesses. Now, of course, some of these, depending on what type of software you're working, you may never actually have to encounter. Like, for instance, some of the various web type ones, if you don't deal with any kind of web or back-end development, you probably won't have to necessarily worry about those as much. Similarly, if you're dealing with a memory-safe language, you won't necessarily have to deal with some of these memory unsafe type weaknesses like the null pointer dereference or the out of bounds reads and writes, because the language kind of handles that for you. But yeah, so those are some of the most common vulnerabilities, and like I said, I have a link to that in the show notes below, so you can go give that a look. So just kind of familiarize yourself with some of those so you can kind of gain an understanding of when they might crop up, and then you can better recognize those instances and protect against them. And that is your cybersecurity tip for the week. And since we got a lot of Thanksgiving stuff to talk about, let's move right into what nerdy stuff have I been up to this week. So this is definitely a light week in terms of nerdy things, largely because I'm only recording this like a few days after I recorded the last episode, because I will be gone for Thanksgiving, and I'm obviously not going to be recording a podcast on Thanksgiving. I will be spending time with my family, as I hope many of you are as well. But I did make some updates to my video game. I did mention I wanted to kind of clean up the script to generate Xcode projects, and I did get that cleaned up, made it more, I guess, style guide compliant, if you will. Like I think I said in the last week's episode, it was a big old mishmash of various casing types, and it worked. It just wasn't, the most clean and pleasant and uniform code to read in the world. So I did go through and kind of clean that up a little bit, and also made it a little more error resistant, because I noticed when I was doing some more kind of testing with it, there were some issues where it would be like, oh, this file already exists, I'm going to crash. So that's obviously not ideal. So I got that fixed, made it a little more error resistant. So overall, it's definitely a lot more well-rounded at this point. And I think it's probably going to stay that way. I don't necessarily see I'm going to make a ton of new changes to it, unless I want to try to add some more fancy things into like the Xcode build process, which I might at some point. But I think for right now, it's probably at a good spot, since it's doing exactly what I want it to. And then the other thing that I kind of did, which kind of occupied a decent amount of the time, was trying to benchmark the new M4 Pro, at least from my perspective of what's important, aka code compilations. So last week I wanted to get this done, but the Xcode generation script thing kind of took priority. So if you're interested in why I didn't do this last week, of course you can listen to last week's episode. But as a benchmark, I did what I did when I was testing my Mac Pro compared to my, let's just say, computer to help developers transition to Apple Silicon. And so I did a very similar test where I took the decompilation of the Pokemon Emerald source code and compiled it on my 2012 Mac Mini, since that's essentially my outgoing machine that I used on a day-to-day basis, my Mac Pro, that very special other Apple machine, and the M4 Pro Mac Mini. So a quick review of the specs. The 2012 Mac Mini that I have has an i7-3720QM, and that is a 4-core, 8-threaded chip. The Mac Pro has two Xeon X5680s, which are 6-core, 12-thread chips for a total of 12 cores and 24 threads. The special Apple computer has an A12Z with 8 cores, 4 performance and 4 efficiency. And my new Mac Mini, of course, is the M4 Pro with 14 cores, 10 performance, and 4 efficiency. So for the tests, I did 5 compilations of the source code and then took an average of each to kind of gain an understanding, just in case there was kind of like a fluke in one of them. So the 2012 Mac Mini was pretty rough. It was just shy of 3 minutes at 2 minutes and 56 seconds. So pretty rough. The Mac Pro did a lot better, shaved basically a full minute off the time at 1 minute and 56 seconds, or 58 seconds, sorry. The special Apple computer did it again even better at 1 minute and 21 seconds, and of course my M4 Pro Mac Mini totally wiped the floor and did it in just over a minute at 1 minute and 5 seconds. So pretty insane. The M4 Pro is essentially 3 times as fast as my outgoing Mac Mini and basically twice as fast as the Mac Pro, which is kind of insane. And then just for the giggles, because the main code that I'm going to be compiling is, of course, my own video game, my Pokemon game that I'm developing. So again, I did another 5 different compile times to get the average. The outgoing Mac Mini, the 2012, was about 16 seconds, I think just over 16 seconds, so pretty rough. The special Apple computer is at 4.75 seconds, so significantly better than the Mac Mini. The Mac Pro was still better than the Mac Mini, but not quite as good at just under 6 seconds at 5.87, and the M4 Pro took everyone out to lunch and did it in 1.93 seconds. So in short, the M4 Pro was basically able to compile my video game, all 5 of the tests, before my outgoing Mac Mini could finish one. So pretty impressive. And here we can again see that the M4 Pro is basically 3 times faster than the Mac Pro, which is kind of wild because the Mac Pro for the longest time was kind of my main dev machine, because I knew, as we can kind of see by these numbers in these past 2 tests, the 2012 Mac Mini wasn't exactly a powerhouse when it came to compile times. Now, granted, it wasn't necessarily a slouch per se, although I will say the past couple years it's definitely been showing its age, so I am definitely still very happy with my upgrade here. But the thing that I do find a little bit weird is how relatively close the Pokemon Emerald compile times were compared to my game. Because, I mean, if we look at it, the Mac Pro was shaved off about a minute. So if the Mac Mini was about 2 minutes, that's basically 33% less for the Mac Pro. But then when you go for the Pokemon Emerald time, but then when you go to my game, it's 16 compared to 6 seconds. So the percentage gap is a lot bigger there. So I'm not entirely sure why. I'm not sure if it has anything to do with the fact that the Pokemon Emerald compile is compiling not to a native application. I did look in kind of the activity monitor to see what when it was doing the Emerald compile, what the application type was, to see if it was like x86 or Apple Silicon. It claimed it was Apple Silicon. Now, I'm not necessarily 100% sure if that was true native Apple Silicon or if that was, there was some Rosetta 2 process where it kind of translated and converted it into an Apple Silicon binary and then ran it. So maybe it's not as optimized. So that's why it's a little bit closer. Not entirely sure, but regardless, it didn't really matter for the M4 Pro since it still beat the pants off everyone in both of these tests. But yeah, that was just kind of my leading theory. Was I don't know if it had to do with it being compiled for a different platform, that being the Game Boy Advanced, or if it just had something to do with the compiler itself wasn't optimized for Apple Silicon, potentially. Not entirely sure again. But while the numbers, are fairly impressive across the board, it gets even crazier when we actually look at the power draw numbers, right? Because while it's nice to see that the Mac Pro can still, for the most part, kind of sort of hang in there. Like it's definitely slower, but it's kind of sort of hanging in there. But then when you realize it's pulling just shy of like 700 watts when it's, doing one of these compile tests compared to the other computers, which are all comparable, like around like the 30 to like 50 watt range, kind of somewhere in there. It makes the Mac Pro's numbers look a lot less impressive. Like, yes, it can churn out some fairly quick compile times, at least compared to the Mac Mini, but then when you look at how much power it's drawing in order to accomplish that, it's kind of a tough sell, especially in 2024. If you were thinking of getting a Intel-based Mac Pro, I would definitely advise against it, because I think the numbers here are kind of clear. Like, Apple Silicon is definitely the way to go, both in terms of power efficiency and performance. You're just not going to be able to get that if you go with the Intel Mac Pro. Now, also, the Intel Mac Mini, when I was doing these compile tests, once again turned into an absolute screamer.
It is a screamer.
Because its fan basically maxed out because it got so hot, trying to do all these compile tests. Whereas the M4 Pro Mac Mini, I never heard a peep out of it, even when the CPU and in the activity monitor was full flat maxed out, doing these compile tests. Didn't hear a peep out of that fan, and I even got like right up next to it and still couldn't hear anything. Now, granted, I was also in the same room where my server rack sits and lives, so there was, the ambient server noise, so that potentially could have played a role into me not hearing the fan. But even still, not hearing any sort of fan noise, even if there was fan noise, it was probably very minimal. So that is also something that was very nice to see. So with that, let's move into the Thanksgiving items as Homelab services and hardware. Now, of course, everyone's home lab is different, so this is just from my perspective, and others will weigh and prioritize things differently. But I think we can start off with the easiest one, which I think you'll probably be able to guess what my comparison will be. So let's first start off with turkey. And I, for this, put a hypervisor. I don't think that should necessarily come as a surprise to anyone, because it's basically the core of my home lab, both in terms of a hypervisor as a server and in the operating system sense. Now, I kept this fairly general as just hypervisor, but if you really wanted to get nitty-ditty into the details, I use Proxmox for my hypervisor, but equally any kind of virtualization hypervisor kind of solution here would work, whether that's ESXi, XCPNG, Proxmox, or any of the others that are out there. So the reason why I, of course, put this is because, like I said, virtualization is at the core of my home lab. And without virtualization and that being a hypervisor, my home lab basically wouldn't exist because everything is essentially running inside a VM except for the servers that are running the hypervisors. Aside from, I guess, my NAS or my network attached storage, but that's kind of its own thing. And in my opinion, when it comes to turkey is like one of those core tenets of a Thanksgiving dinner. Like, it's kind of one of those, if you don't have turkey, it's like, is it really Thanksgiving? But that kind of moves us into the second one on the list, which is ham. Now, ham isn't necessarily as prominent as turkey, but it's still a option that some people like or prefer over turkey. So I kind of have this as the dark horse, and kind of as a comparison to virtualization and hypervisors and VMs. I put containerization for this one, specifically Docker in this case, because I happen to use Docker. Now, like I said, ham isn't necessarily as common of a Thanksgiving item, but it is a common substitute for turkey, or even served in conjunction with it. And similarly in my home lab, that's essentially the role that Docker serves in my home lab. But even like excluding my home lab, you can still build a solid home lab setup strictly using Docker containers. For me, it's just kind of a preference thing on how I want to run the service that I'm trying to run. Like, personally, I prefer kind of a mix of using Docker containers and virtual machines. Like I said, it kind of depends on what I'm trying to accomplish and what I'm trying to do with it. Like, if it's kind of a standalone service that is fairly easy to spin up, I might just opt to do it in a Docker container. But if it's something that I kind of want to get into and kind of play around with and tweak things and mess with settings and stuff like that, then I might opt to go with a virtual machine. I mean, it's really a kind of more of a case-by-case basis thing. But a lot of things that you can run standalone in a virtual machine, you could run in a Docker container, or vice versa. Things that you can run in a Docker container, you could run in a virtual machine. There's a lot of overlap between the two. And even if something doesn't exist as a Docker container, you could make it into one. If you have the know-how about how Docker works, you can write your own Docker file to build your own containers, and then you can deploy your own stuff. So definitely very comparable and kind of, in my opinion, complementary to virtual machines, although you could also do a complete substitute like you can with ham and turkey. Getting into the next one, which is kind of another core piece of a Thanksgiving dinner, in my opinion, is mashed potatoes. And for this one, I decided to go with a firewall/router. In this case, I went with pfSense since that's what I use. And first off, don't tell me that you've never carved out a crater in your mashed potatoes and poured gravy in the center to essentially make a mashed potato gravy volcano. Because I know I definitely have done that. But as a very kind of specific example, just like mashed potatoes in this case of the gravy volcano kind of serve as a barrier to keep the gravy from flowing everywhere on your plate, that's kind of what a firewall and router do, kind of controlling the flow of network traffic to make sure, things aren't getting in that shouldn't be, and you're only letting things in that should, and kind of controlling that flow. So that's one reason why I kind of put that. Also, a solid router and firewall is kind of another core tenet of a home lab, at least in my opinion, just like mashed potatoes are a core part of Thanksgiving. So I kind of already touched on gravy, so why don't we just move right into gravy? And gravy, I decided to go with Ansible. Now, I know Ansible technically isn't a service that you run in a home lab. It's kind of a tool you use to augment it and kind of manage it and all that kind of good stuff. But at the same time, I wouldn't necessarily call gravy a food item per se. It's kind of more of a topping, like an extra type of a thing. But the reason why I gave gravy Ansible and kind of compared the two is they both kind of tie everything together, right? Gravy kind of ties the whole meal together. You put it on basically everything on your plate, and if all your food items aren't covered in gravy, what are you doing? But also, it just kind of complements everything so well, just like Ansible complements a home lab so well, because any services you want to run, anything you want to automate, doing updates, pretty much anything you want to do, you can do it with Ansible. And kind of this idea of, using infrastructure as code, if you will, the fancy technical businessy term there. The nice thing about that is you kind of self-document in a way, because if you write Ansible playbooks to install and configure services for you, you pretty much have the documentation writing itself as you write these playbooks. Like, you don't necessarily have to worry about writing a bunch of different wiki pages on how to configure a bunch of different services you run if you can just write Ansible playbooks that can do it all for you. Now, granted, you have to validate that the Ansible playbooks worked, because, when you update to different operating systems or different versions change, some of the configurations that you have to make might be different. So there are some, of course, some things you have to validate and check and verify. But even still, it makes your life a lot easier and kind of makes, ties everything in the home lab together. Ansible does, just like gravy. Moving into the next item, I have stuffing. Now, I think, or I guess dressing, depending on where you're from. But for this, I gave the network switch. And just like a firewall and router, a network switch, in my opinion, is an essential piece of any home lab, especially if you have a large one, in order to make sure everything stays connected. Now, if you only have like one or two devices, you don't necessarily need a network switch per se. You could probably use the built-in RJ45 jacks on your router that your ISP gave you, or I guess you could use Wi-Fi too if you wanted to do that. But if you really want to connect a bunch of different computers together, or you have computers with a bunch of different network interfaces, like you either have an enterprise server or you bought a extra add-in card for like a desktop PC to add more network ports. Either way, you're probably going to want to connect and network everything together, and a network switch is kind of an essential part of that in order to make that happen. And also, kind of in a more literal sense, stuffing is kind of an amalgamation of components, from bread cubes to celery, onions, any other kind of vegetables. It's kind of an amalgamation of things, just like a network switch is an amalgamation of different types of networking ports, like your RJ45 connectors, SFP, SFP+, QSFP, depending on how baller your switch is, things like PoE or power over Ethernet. So things like that. Stuffing, again, is kind of a core tenet of Thanksgiving, just like a network switch is to a home lab. The next one I wanted to talk about was kind of, I guess, cheating a little bit and kind of lumping two in one, which is either bread and or rolls. I put bread/rolls here mainly because sometimes some people just have rolls as their bread. Other times people have loaves of bread. It doesn't really matter. Usually there is some kind of bread component in a Thanksgiving dinner. And for this, I decided to go with a NAS, or network attached storage. And a solid loaf of bread or a collection of rolls can really tie a Thanksgiving together. I mean, how are you going to mop up all that extra gravy on your plate if you don't have a piece of bread or roll to do so? But they can also be very dangerous, because you could find yourself easily filling up on the bread before, you really got into the main Thanksgiving meal. And in a home lab, a NAS can be basically as basic or as extravagant as you want it to be, just like your bread. You could fill up your NAS with your media library. You could fill it up with virtual machine backups. You could fill it up with, random files. But also you could kind of put in tons and tons of terabytes worth of data into it, or you could make it very slim and fast with like all SSDs, but not as much data. I mean, you can basically do whatever you want. But also, you can go with various different options for both a NAS and your rolls and or bread, because in the case of the NAS, you can go for like a pre-built option, whether that's like a Synology, a TerraMaster, a QNAP, or something like that. Not to mention, you can get as small or big of a NAS as you want. Like you can get pre-built NASs that only have 2 bays, or you can get ones that have like 8 bays. I mean, you can get differing sizes depending on what your needs are. Just like for bread and rolls, you can buy them at the store and and they get the job done. But also on the flip side, you can basically go as ham as you want and do a homemade version if you want. Now, from the NAS side, this would be anything from, sourcing your own components to essentially build your own PC essentially and kind of DIYing the solution, or just kind of picking up a used computer or used server and kind of installing your own NAS software on there, whether that's TrueNAS or Unraid or something like that, and kind of using that as it. Installing, not Open Media Vault, OwnCloud or Nextcloud, installing, something like that to kind of make your own cloud service. So there's a lot you can do with it, kind of the DIY version. Also kind of and then going back to the bread side of things, you could also make your own homemade bread for Thanksgiving as well. But in either case, if you're going the homemade DIY version, both cases are a lot more work than just buying something off the shelf. But in my opinion, they're also a lot better, and you can also make them to exactly the way you want it, which is kind of a nice benefit. So the next item we have is the sweet potato casserole. Now, is it a side? Is it a dessert? Who's to say? But I compared this to development environments, because are development environments services you run in your home lab, or are they just playgrounds for you to mess around and test with stuff? Who's to say? You could try to sell a sweet potato casserole as a side dish if you want, but you also just kind of have to try and overlook all that butter and sugar that goes into it. Just like you could try to sell your dev environments as services and virtual machines you manage in your home lab to pump up your numbers in regards to how many things you're running in your home lab, but you also just kind of have to try and overlook the fact that they only serve a singular purpose to play around with something specific, and if we're being honest, they could be shut down 99% of the time and have no actual implication on anything, and you only boot them up when you actually want to play with them. But let's be honest, you don't do that. You just leave them running all the time because you want that on-demand access, even though you never really use it as on-demand access. Definitely not speaking from personal experience on that one. Getting into the next one, I have mixed vegetables. Now, mixed vegetables is essentially just a collection of vegetables all roped into one dish. Thank you, Captain Obvious. And a media server is essentially the same thing, but instead of for various vegetables, for different types of movies, TV shows, music, podcasts, books, any other kind of media. And you can essentially kind of create your own in-house streaming service if you don't want to have to deal with all the various subscriptions. The next one on the list is corn. Now, I did split this out from mixed vegetables, even though corn can be in mixed vegetables, but I kind of split this out partly because you can do corn, by its own, and usually I think it's kind of also its standalone thing, but we're getting a little bit ahead of ourselves. I compared corn to a Git server. In my case, it would be GitLab. But some people tend to pass on the corn when it comes to Thanksgiving, but I am not one of those people. And in a similar vein, non-developers will pass on hosting their own Git server, but again, I am not one of those people. But like corn, a Git server can be as basic or as fancy as you want it to be, because you can do fancy things with corn, like doing a creamed corn or do corn on the cob or add various seasonings to it or just make it plain. And in a similar vein with a Git server, you can use it literally just as a remote host for your code or config files or whatever. Or you could have it set up to run complex continuous integration and continuous delivery or CI/CD pipelines for automated integration, testing, and deployment of various applications and services you run and or manage. So there's a big spectrum of things that you can use a Git server for. So that is why I selected that for corn. The next one on the list is cranberry sauce. So first off, what even is this, and why is it a part of Thanksgiving? I'll never know. But kind of on a more serious note, I relate cranberry sauce to pie hole, since like my pie hole instances, I completely forget about their existence. And like cranberry sauce, I completely forget about its existence at Thanksgiving. And the reason why I forget about my pie hole's existence is because how integrated they are into my home lab and are so seamlessly integrated that I often forget that they're there. The only time I really realize that they're there is when I leave my home Wi-Fi and realize how horrible the internet is with all the ads everywhere, especially on mobile, my goodness, before I then reconnect to my home network through my VPN that I have set up. So that's pretty much the only time I realize how spoiled I am with Pi-hole, but oftentimes I just kind of forget that it's something that's running in my home lab, just like at Thanksgiving I often forget that cranberry sauce is even a thing. The next one on the list is green bean casserole, and I equate this to monitoring, and specifically my monitoring solution of choice, at least from the dashboard perspective, is Grafana. And this is another one of those dishes that could be considered iconic, but I also feel like a decent amount of people pass on it, or maybe that's just me that tends to pass on it. But like monitoring in a home lab, it's something you definitely do not need to have, but depending on how hardcore of a home labber you are, you might say that having a solid monitoring solution is an absolute necessity. So there's really kind of two camps, right? Like just like with green bean casserole, I feel like some people are like, it has to be there. It's a core component of Thanksgiving. It must be there. And then other people just kind of shrug their shoulders and are like, meh. So just like for me, for instance, if there's no green bean casserole, you definitely won't see me shedding any tears about it. Just like some people in their home lab, they don't have a monitoring solution and they could honestly care less. That was honestly me before I discovered how cool it was. So I guess to each their own. But the hardcore home labbers and Thanksgivingers, not sure if Thanksgivingers is a word, but I'm going to roll with it, will definitely argue that monitoring is an essential part of a home lab, and the Thanksgivingers will argue that green bean casserole is a essential part of Thanksgiving, and it ain't Thanksgiving without a green bean casserole. Now let's move into the dessert options for Thanksgiving. And the first one that we, of course, have to touch on is pumpkin pie. And I am equating this to an X-serve. And arguably, pumpkin pie is probably the best part of the meal, and an X-serve is the best part of a home lab. And of course, at least in my opinion, and of course, I am very biased. But seriously, pumpkin pie is a dessert, and as such, you're probably not going to be eating your entire Thanksgiving meal as just pumpkin pie. But if you are eating your entire Thanksgiving meal as just pumpkin pie, I have a couple questions for you. My first question is, how many pumpkin pies do you have to make for Thanksgiving for your entire Thanksgiving meal to only be pumpkin pie? And my second question is, can I come to your place for Thanksgiving next year? Let me know. But just like pumpkin pie is made to be a treat and not the main course, that's kind of the same vein that the Xer falls into, at least in 2024. Now, if we were talking like 2014 or 2004, then an Xer would be an absolute ballin' piece of machinery to have running in your home lab. 2014 would be kind of stretching it maybe a tiny bit, but it still would be definitely very viable. But nowadays, if you value your electricity bill as well as your sanity, if you have to be anywhere near this thing, because, mind you, closing the doors isn't good enough, you won't be running an Xserve 24/7. You'll only be turning it on when you want to play with it and you aren't around, which is why I run my backup scripts when I'm away from home, so I can just let the Xserve rip and I don't have to hear it. But also, pumpkin pie is like a treat after Thanksgiving. The Xserve is a treat for your server rack, since one thing nobody can deny is how beautiful an Xserve looks all racked up in a server rack. And if you've never seen it, look up on, just search images on your search engine of choice, Xserve in a server rack or something, and I'm sure you'll find pictures. It's one beautiful looking machine, and is basically kind of a standout piece of any server rack, especially when you're used to seeing kind of the bland, boring server colors and designs that are on modern servers these days. But keeping with the dessert train, let's go with the next one, which is apple pie. And I am comparing this to a retro computer or retro tech in general. Now, there's going to be debates on which is the better pie dessert, that being pumpkin pie versus apple pie. But in either case, both are to be enjoyed, but also not as the main entree, right? Generally speaking, again, unless you're that person from before where all you eat is pumpkin pie for Thanksgiving, which if you do, let me know. But usually that comes after you've already had your turkey and your gravy and your mashed potatoes and all that good stuff. It comes as the dessert, right? And just like having retro computers in your home lab, it's really fun to break them out and play with them from time to time, but it's not like you're going to be using your retro computers as your daily drivers, right? You're not going to be busting out like an OG iPhone to use as your main phone. You're not going to be, busting out, a Commodore 64 to, do your word processing. I guess you might be able to, but probably not. So at the end of the day, though, it is fun to, kind of break it out and play with it from time to time. But I guess it also kind of depends on what you consider as retro technology, since depending on your definition, I was technically using retro technology on a daily basis up until a couple weeks ago. But again, it kind of depends on what your definition is. But also depending on what your definition is, I am still technically using servers that are running Ivy Bridge Xeons from 2012, so I don't know if you would consider that retro or not, but if you do, then I guess I'm still technically running retro technology on a daily basis. But I'm hesitant to give a specific definition on what counts as retro, because it's kind of an ever-moving goalpost about what is considered retro, and it kind of also varies from person to person, depending on how old or how young they are. And because of that, I am bound to make someone feel old that did not want to feel old, so I'm just not going to give a definition. But what I think we can objectively agree on is that a device has a few different stages of its life cycle, right? So it has the stages. At a certain point, when it stops receiving updates for a certain number of years, I think it's safe to say that it becomes retro at that point. Now, how many years that is, I'll leave that up to you, but I think there's kind of levels to this. Like, you go from the device just being old, which is it's still technically supported, but not for much longer. Then you have outdated devices, which are no longer supported for some number of years, like they haven't been supported for, 1 year. It's technically outdated at that point, so it's no longer supported. How long that range extends, I'll leave that for you to decide. And then it kind of comes into the retro phase, where it's been unsupported for long enough to the point that you kind of have nostalgia when you go back and view the last supported operating system it was running. I feel like that's at least kind of a objective level to gauge if something is retro or not. Again, those ranges and what can give you nostalgia, I guess, is up to you. But tangent aside, retro computers are definitely fun to indulge in, but you aren't going to be dailying them, kind of like I said. Just like apple pie is nice to eat for dessert, but if you eat only apple pie for your Thanksgiving, while it might be very awesome and very yummy in the moment, you probably won't be feeling that great afterwards. And the last one that I kind of want to touch on is whipped cream. And for this, I am going with Bash and or Python, or really any scripting language. And I know I said I wouldn't do programming languages, but you have to hear me out on this one. So kind of like the gravy example, whipped cream is more of a topping, and it's not really any kind of a side or full meal or even a dessert. It's like a topping. So in the same vein, Python, Bash, or really any other scripting language aren't the core of any home lab and really aren't something that you run in your home lab, kind of like Ansible isn't, right? But what they do, they make your life a lot easier and are a nice kind of topping to add on top of your home lab to help automate things. But unlike gravy, which basically goes over the entire plate, whipped cream is kind of a more specialized use case, right? You're not putting whipped cream on your turkey and mashed potatoes. At least I don't think you are. If you are, I guess let me know. But I don't think most people are. Most people are probably reserving the whipped cream for either the pumpkin pie or maybe even the apple pie. So it's a lot more of a niche use case. Just like kind of that's the same thing with Python and or Bash, right? Like you're not necessarily going to be using Python to automate everything in your home lab, but there's probably some specific niche use cases where you want to automate something and you can either write up a quick Bash script or write a Python script to kind of handle that. But your large kind of automation stuff to kind of manage the entire home lab as a whole is probably going to be done with Ansible or some other infrastructure as code thing, like just kind of like gravy kind of goes over your entire plate, whereas whipped cream is kind of more specialized. So what did I miss? Because I'm sure I covered a lot of Thanksgiving items and dishes, but I'm sure I probably missed some, and I probably didn't give the right correlation to the dish to the home lab service that you wanted to hear. So if I missed something or didn't correlate them correctly, definitely let me know either at an email or down in the comments below if you are on YouTube. But before we go for today, let's get back to our Thanksgiving-themed trivia question, which is a recipe is a common analogy for what computer science and mathematical term defined as a sequence of steps or instructions to solve a given problem. If you said an algorithm, congratulations, you got this week's trivia question correct. And like I said, I hope you had a good Thanksgiving. Hopefully you got to enjoy it with some friends and family members and had some good food along the way. And if you enjoyed this episode, definitely be sure to share it with a friend or family member and leave it a review and subscribe if you haven't done so already. And if you have any questions about this episode or have any comments, ideas, or topics for future episodes, shoot me an email at contact@darkassassinsinc.com, or if you're on YouTube, you can leave a comment down below. And that's going to do it for me in this episode of the Dark Assassins podcast. Until next time, my fellow assassins, remember, bool nothing equals true. If action not equal to null, return true. I'll see you next time on the Dark Assassins podcast.